Thank you so much, Katie, for doing that.
I'm going to jump off, but wishing you all well and talk soon. Bye.
Awesome. Thanks, Katie.
Oh, Rosemary, I'm going to pass you back host. Okay, go ahead. Sorry.
All good. Fantastic. So let's kick off this, our first virtual HashiCorp user group for Perth. Just welcome. My name is Bruce. We've got some amazing guests today. I think we've got just, that's it. So we've got Rosemary from HashiCorp, and we've also got Jason from Gremlin. We'll go through those in a second, but I just want to say thank you, guys. We've been pretty fortunate to have such, well, I mean, I guess it's the unique situation that we're in. We're able to get some amazing panelists and talk today about what we've got today is testing. So we're going to do infrastructure testing as well as chaos engineering. So we're going to kick off first of all with Rosemary Wang. She's the developer advocate for HashiCorp. We're going to talk through infrastructure testing, and straight after that, we'll talk to Jason Yee. He's the director of Advocacy at Gremlin, I believe, which is a chaos engineering software as a solution system. So I'm going to hand it over to Rosemary, and she's going to blow our minds about testing with infrastructure as code. No, not at all. Awesome. Over to you, Rosemary.
Thanks, Bruce. I don't know if I'll blow your minds with testing. It's evening, so you'll probably be like, no, can't process this. Before I continue, though, I just wanted to make sure, can everybody hear my sound okay? I just want to make sure that audio is okay. There's not too much noise. Unfortunately, due to the circumstances, there are multiple occupants in here. So, and I'm also going to take the virtual background off, mostly because the green screen can be a little distracting. Okay.
Good.
All right. So what it all started was that I was working on a bunch of infrastructure, as I usually do, and I wasn't really sure if it would work or not. And I was working as a consultant at the time, and I worked with a lot of developers who were really curious about testing. They were in this practice of writing many different types of tests. They were in this practice of basically writing unit tests for very specific functions, running through those really quickly, and then proceeding to sort of the next stage. We were using something called microservices, right? And then we would contract test those microservices. We would say, does this microservice API match the input that we're expecting to go into this other API? So it was a really interesting, complex system and this very massive testing strategy that was across the set of microservices. And the question that I got was, why can't we do this for infrastructure? So I started to think about this a little bit more carefully to understand what was actually infrastructure testing and why it actually made sense to do it. So the result was that I actually started to teach a lot of my fellow other people who were interested in this to learn a little bit more about infrastructure, and I did it through test-driven development. I'm not going to go through this whole presentation. You can go see it yourself. If you type in TDD for infrastructure, you'll find it. There's a recording of it. But you'll see there, I'll be borrowing a little bit of these slides, not for any particular thorough discussion of testing, but I'm going to focus specifically on two types of tests, unit and contract. So there's a whole, like I said, there's a whole presentation on this TDD, how it works, but I wanted to briefly highlight the TDD testing, or in TDD, the testing pyramid. Now it's not TDD specific, but it kind of helps to drive a better understanding of what you would do with tests in infrastructure. So the testing pyramid is a theory that basically says the type of tests that you write are more costly in terms of time and money as you go up the pyramid. So you have unit tests at the bottom, contract tests, integration tests, end-to-end tests, and manual tests. And when you're trying to assess whether or not infrastructure works, traditionally, at least when I was looking at networking, right, I would plug in, some code or CLI commands into a switch, and then I'd wait. And I would wait to see if it worked or not, basically. And most of the time it was a manual test. I would basically check if a packet could go from point A to point B. Now there are more complex and more elegant ways of testing networking. For example, you might run an end-to-end test to say, like, can I ping from point A to point B? And is that something that I run in an automated way? But it's still pretty expensive. And as I started to evolve the way I was teaching infrastructure testing, I ran into a lot of people who told me, I don't want to spend money on dev infrastructure or staging infrastructure. I don't want to spend money testing infrastructure. I want to just run this against production entirely, which to my point was, well, what happens? How does it work from a risk management standpoint? And it slowly grew on me that the continuous delivery model, right? The idea that you try to backload as many unit and contract tests as possible before you get to production might actually be a way to think about this in a better way. So we're going to focus on what unit tests are like in infrastructure and what contract tests are like. And we're going to do that with code. So I'm going to actually switch it to a code screen. If you can't see it, please do let me know. It should come up soon. I just want to pause if the font isn't great or if you need it a little bit larger. I'm happy to increase it, but just do let me know if you want me to increase it. Either drop it in chat, and if someone on the HUG can wave at me and say, hey, can you increase the font? I'm happy to do that. Okay, so I'm going to get started with some code. The idea behind unit tests are that unit tests are self-contained. They shouldn't really depend on anything else to run. So let's say you have a function that basically iterates through and checks if a number is 1. You want to write a test that assesses whether or not that function checks the number is 1. And that function should be self-contained. It's not, reaching out to APIs and saying, is this API 1? You can do it, but it's there's mocking, et cetera. So unit testing can be a little complicated. But in infrastructure, as you can imagine, unit testing is a little strange. It's not quite as perfect as saying, is this function 1? So what I actually have here is I actually created some Terraform, and the Terraform creates some Azure networking. So here it's fairly straightforward. It's just got some resource groups and a subnet and a virtual network. Nothing complicated. We're not going to spin up massive infrastructure right now, but I wanted to show how you take a piece of the puzzle, so to speak, and unit test that. So let's say I do want to unit test this, and there are some things that I can unit test and I can do. What you're going to see today is actually a conf test. I just have some more familiarity with conf test in the unit testing space. You can use any tool you want to. That I have a whole list of them. So if you're curious for more information or you want to know a little bit more about the types of testing suites you can use, you can refer back to that TDD deck that I referenced before. So here, you'll see that there are a couple of interesting statements here. The language is less of the concern, but more of this is to understand what you're trying to test for. And I have a habit of misappropriating security testing frameworks for unit tests, because I do think that those actually have some overlap. So if you're familiar with Terraform Sentinel, which is the policy as code framework, Terraform Sentinel, right, is checking for certain things to exist in plan. It's checking for certain resources to be stated in the way that you expect it to. And in that case, you can use those policy as code frameworks to sort of layer on some unit testing. So here, same concept, it's just using conf test. So what you'll see here is that there's a virtual network, and all I'm checking is that if it defines the virtual network, right? What this is actually looking for specifically is this resource file. So it's actually looking for network.tf, and it's actually going to, as part of the conf test language, I can say, here's my input, here's my hierarchy, resource, Azure Virtual Network example. So that's all it's doing. It's saying, does it exist? If not, then flag it as a problem. Similar thing for Azure Subnet. So these are unit tests, right? It's just checking, does this function exist? And does this quote unquote function exist? We're taking liberties with the semantics, but does the function exist? So the next piece of this, which is really important to understand, is that let's actually do some more complicated and in some ways more functionally significant unit tests, right? So one of these is actually something like, maybe let's just check that I actually used a variable in my address space. So for those who are more familiar with Terraform, it's easy to just hard code in a string for your CIDR block, but maybe you want to make sure that you've actually used a variable. And in that case, that's something that you could reasonably unit test. So in this case, same concept. I looked for an input resource, Azure RM virtual network example. So I'm looking for my virtual network example, and I'm going to check this address space here, right? So this address space should have variable CIDR block. Notice that this is a hard-coded string interpolation. And the reason why it works this way is partly because it actually casts it as a variable string interpolation. So it looks like Terraform 0.11, but not really. So what it's actually checking for is, does it contain the variable .CIDR block? Does it contain this variable parameter? And as it so happens, if we're doing TDD, this address space will not pass because I've actually hard coded in 10.0.0.0.24. So if I actually run it, I'm actually abstracting it behind a make command. The reason why is that, again, it's less of a concern kind of which unit testing framework is it. It's more of the approach. So here you'll see I have actually flagged it as a problem. 10.0.0.24 is a defined CIDR block. It doesn't use variables. So I have a very descriptive notation here to use variables. Now, someone told me once that this seems a little bit like linting, right? It seems a little bit like you're checking for good standards in your Terraform code. And yeah, to a certain degree, infrastructure unit tests can be formulated in that way, mostly because a unit test being self-contained may or may not actually reflect the true values or some of the logic or the functional logic you're putting into your Terraform. So that to me actually is more representative of a contract test, and I'll explain why later. But the idea behind here is that what we're looking at specifically are things that we can test within our Terraform resource configuration. So I could even look for, if I decided to hard code the name going forward, I could even look for the specific name. The idea is that, notice I'm not logging into Azure. I'm not logging into Terraform. There is no Terraform init or Terraform plan or Terraform apply in any of this. I am specifically checking the resource configuration here. So by isolating that, I can also do some interesting things. So for example, I also have a unit test here that says network should have 2 subnets, but instead I got length keys local, right? So this is actually what I was saying before about not testing the logic, right? So part of the problem with this approach to unit testing your Terraform configuration is that if you do have logic like this, like length keys local.subnets, you have no idea if this actually equals 2 or not. And in that case, it's not really a traditional unit test in the software space. But here, maybe what I'll say is that I do want it to be more importantly, I don't want it to be a hard-coded variable. I want it to make sure that it's like, it's specifically length keys, something like that. So I could change this here to, let's make it pass. If it's not equal to length local keys, let's just do that. We'll make it pass, which is, of course, the problem here is that I need it to be interpolated. Like I said, it's partly the way that the conf test kind of reads these values is as an interpolated value. So just for the sake of completion, let's actually get this last unit test passing. So here you'll see 10.10.0.0.24, and in which case you want to actually put, let's say, this var CIDR block. So I'm actually going to do this and fix this here. And I don't want the interpolation because this is so.12. So after I get that, the idea is that now my unit tests pass. Unit tests, they'll only go so far in Terraform, right? Because most of the time when you're doing a lot of Terraform, you're taking advantage of Terraform functions. And in most infrastructure, you're relying on list comprehension. You're relying on, conditionals to create that infrastructure. That's why you're doing it as code. So unit tests, again, look a little bit like linting, but the idea is that maybe there are certain standards you want to ensure that you have, or maybe you do have some hard-coded Terraform resources that you do want to make sure exist in some way, shape, or form. So what I'm going to do is, in true sort of continuous delivery format, I'm actually going to push this up. So we're going to see if the hooks work today. So we're going to commit this fix unit tests. Oops, sorry. Git commit fix unit tests. So what this is going to do is actually it's going to fix my unit tests for me, and it should actually run it into a pipeline. So I've actually connected up a pipeline here. Did I push this? Let's see if it works today. No, I didn't push it. So the idea is that let's say you refine your infrastructure. Maybe this is part of your making updates or you're refactoring your Terraform code. You commit these new fixes or these new changes and you push them up. And what you should basically put together is a pipeline, right? The pipeline itself will deploy your infrastructure, but before it ever gets to production, you want to make sure that some of these parameters are fulfilled. So as you can see, I've put a very simple pipeline together. It does not have an apply because I don't intend to apply this infrastructure. But the unit tests here would run before I even applied it. And it actually even runs before I even plan it as well. So part of this particular pipeline that you'll see is that it runs the unit test. So as you can see here, it did run that network unit test that we were talking about earlier that we got to pass. And it also did a Terraform validate just to make sure that things looked good with the Terraform. So that's kind of the way you would unit test. While I think that unit tests can be useful for some things, I will say that in terms of infrastructure, you may find yourself sort of struggling or writing them in redundant ways. So really be judicious about what you do unit tests. Sometimes if it is hard-coded infrastructure, so if you're hard-coding a CIDR block or you know this is like an address space, for example, that you're never really going to change, or there's some count variables that you're always going to have, you could actually do some unit tests on that and it would make a lot of sense. But most of the time, tests are for communicating sort of functionality or intent to someone else in some regards. So if it's going to help communicate to someone and help them understand why they're doing it this way, or there's something nuanced or there's something manual about this process that they need to keep in mind as they're building on this infrastructure, a unit test is a good way to at least give that heads up to someone else. So that's why, if you do a unit test, just think about which ones you would apply and which ones would communicate that to someone else. So that's the unit test. Now here's the next one that I actually prefer quite a bit. It's a contract test. And you'll hear some people call it a state test in infrastructure. I call it more of a contract test because to a certain degree, state is output, state is also expected input, right? So outputs, inputs to the executing system. So state to me represents more of a contract test. So if you're more or less familiar with the microservices space, right? The contract test is representative of, do I match for a service that's calling here to a service that is receiving that information there? So it's checking inputs and it's checking outputs. As you can see here, I have a stage in my pipeline that does do a contract test. So what you'll actually notice is that my contract tests fail. And we're doing this TDD, so now we have to get these contract tests to pass. And I'll show you kind of why contract tests are sort of related to state testing. As you can see, there is a plan. This only works if you actually run Terraform plan. The idea is that it does need some indicator of what resources are changing. It does need an indicator or a dependency of some upstream existing state that's in whatever cloud provider you actually are using. In this case, it's Azure. So in this case, it does need Azure access, it does need Terraform plan, and it does need access to anything else that it would require, like remote state. So this is the important nuance with state testing, and that's why, again, I don't really consider it fully a unit test, mostly because it is not really self-contained. By definition, it doesn't fall into sort of the unit test, traditional unit testing definition. But the bulk of what you might actually end up doing in Terraform testing will probably end up being a contract test. So here I'm using conf test, and I'll show you actually under all of this, what is it actually checking. So if you are curious about this repository, you can find me on GitHub, Jack of all trades, master of none 08, JOATMON08, and this is TDD infrastructure. You'll actually be able to look at the TF Azure network code, and you'll see this kind of similar testing framework here. So what you'll see actually is a contract test folder under test, and this is actually where the contract test is being run. So as you can tell in this lovely giant Rego expression file, what you'll see is that it's checking for a few things. Remember before we talked about getting those resources Azure Virtual Network example? Well, the contract test here is not checking the Terraform configuration. It is not checking the Terraform configuration. What it is doing though is checking a JSON configuration of state. So when you run Terraform plan, you have the option of exporting the plan. And then you can show that plan in JSON form. So the commands roughly look like this, right? You can Terraform plan, you write it out to a file, and then you can show that schema in JSON. A lot of people use this JSON for many different ways, shapes, and forms, but it is in itself the state file sort of schema-ish into a JSON formulation. So you'll actually show JSON. So this is actually something you will need because it will compare existing state with the new state you're planning to use. As a result, it is truly state testing or contract testing. So in this particular contract test, right, we're actually going to be parsing this JSON here. And unfortunately, when you actually output it, it doesn't look that great. You have a pretty big schema here, but it's a nice way to show kind of what is going to be changed. You have root module resources. So all of what you're going to see in many of the tools that execute on contract testing or state testing for Terraform, they're actually using this JSON. They're writing it out and they're actually parsing this JSON and checking for values. So you could write your own tool. You could use Jinja, whatever you want to parse this JSON and then check the values. But the idea is some of these tools make it a lot easier, so you don't have to write it yourself. So in this case, conf test, we're actually going to check a couple of parts of the JSON, and I'm going to open this to the side. So it's a little hard to see, I know, because the font is gigantic, but that's okay. So what you'll see here is that I'm actually parsing resources out of the plan values, root module resources. So you'll see plan values, root module resources here. And I'm actually checking if the address matches, let's say, Azure RM virtual network example here. So Azure RM virtual network example. So I'm matching this address, right? So it's retrieving any kind of resources that match this address. And then what I'm going to check is whether or not the address space matches my expected address space. Now remember, we pass it in as a variable, right? So this is where it's actually very powerful to use sort of a contract or state test to assess this. Remember in our unit test, we changed the address space to a variable. Now, how do we know that that variable got populated correctly? It seems really simple. Terraform should just pass that variable, but maybe we're trying to be particularly vigilant because these variables change across staging versus production. So we do want to make sure that it's very specific in its CIDR block representation. Maybe we've allocated these address spaces in our data center. So we want to really make sure that these are correct. In which case, I want to say, let's make sure that the address space is 10.255.4.0.0.16. That's the input to my variable CIDR block that I wanted. So what you'll see here is, well, in my previous state, this was not correct. This was because it was hard-coded previously. So what I'm actually going to do is let's just see if this test passed now because I refactored my unit test, right? So make contract is just, again, abstracted. It's a command. It just abstracts all of these steps for me, so I don't have to worry about it. All right. And as it regenerates it, you'll notice now the good news is that it does not have a failing test for that, but now it has a problem with the two subnets, and now it has the resource names must have environment. So one important part about this is that again, be judicious about your unit test, right? Was it effective for me to have a unit test to test two subnets when really I was already going to do that as part of my contract test? And the contract test is probably in some ways more informative than the unit test. Well, the reality is probably this is something you should just test as a contract test. It's not something you would test as a unit test. So in which case here, I'm actually looking for two subnets, right? So what you'll see is that I'm looking for Azure subnet example, but I'm making sure that the number of subnets that match that prefix is 2. And as you can see, the answer is it's not 2. I think it's 1 based on this. So what I'm going to actually do is I'm going to fix my network Terraform to actually do this correctly. So I know the answer right now, but the idea is that right now, as you can see, this count is based on the keys of the local subnets. So what I'm going to do is notice there's subnets front end, there's one key. So I'm going to actually create a second key. And just for, CIDR block, let's say you can also check these functions as well, which is kind of nice. Let's just say it's going to be the second one. So this is a really quick way for me to say, okay, let me just create the second subnet, make sure this logic is good. So that's my first refactor. Hopefully this test pass. What's actually kind of neat about this approach as well, 3 tests, 2 passed. So you'll see 3 tests, 2 passed. So we only have 1 left to get passing. But I wanted to focus a little bit on this test specifically. Remember, all it said was, are there 2 subnets? It's not checking what type of subnets. It's not checking the names. So you can get more complicated with some of these tests. But more importantly, if you're using O.12 and you're refactoring some of these constructs and some of these meta arguments out of your O.12, how do you know that you still preserve the same logic, right? And so what's really neat about this approach is that just because this is count doesn't mean it has to stay count. I could just say for each local dot subnets, right? And what this will do is actually allow me to refactor this entirely. So I won't go through it too much, but let's see how fast I can do it. So I can say this is an each.key, right? So I can use a different construct in Terraform to actually look at this. And now I can say actually each.value, which, seems pretty simple, right? It seems like it's a lot simpler, a lot cleaner, but do I know that this is actually right? Well, the answer is I can always run the contract test again, and this allows me to check whether or not it affected my state. So if it did change, it lets me know that this functional approach didn't work. I can take it away. But as you can see here, it's kind of neat. 3 tests, 2 passed, still, we have 1 failure. So same logic, just different meta arguments. And that's where the true power of that contract test comes in. The ability to go in and be able to change some of the logic you have in your Terraform and assess whether or not it changed state. So I'm not going to go through this further. I actually will leave this exercise to you to sort of figure out what this last test is if you decide to go through it. The idea is that you want to continue getting some of these tests to pass. In terms of writing some of these tests, kind of where you get started is usually, you think about what you want out of your Terraform, right? So if it's 2 subnets, if you have some complicated logic that you're parsing through like 7 different virtual machine configurations, you don't know if it's right, you don't know if it's wrong, you don't really want to spin up 7 virtual machines all the time. It takes a really long time. Go through this process, use ConfTest or use even Sentinel. And there's actually even some Sentinel code here that does the same exact thing. All it's doing is checking whether or not these things are what you're expecting out of your contract test, right? So use the tools that you have, take a look at what is complicated in your Terraform configuration, what logic you might feel better going through and parsing, and actually write the test for it. See if it matches your expectations. If it doesn't, then either the test needs some refinement or that your configuration isn't quite ready yet and you need to refine that further. And with that, I will leave you with the particular link here, which is the speaker deck. It will actually have sort of at the end a slides page, but you can also find the GitHub with TDD, etc. So you'll have a lot of resources available as part of this deck. And you can actually choose other tools that are not just ConfTest, which is what you saw today, or Sentinel. You have many others that are in Ruby and Python as well. Okay, thank you.
Awesome. Thanks, Rosemary. That was awesome. I enjoyed that. We actually use Sentinel at VGW, and it's a great product. It's great to verify your code and also just give you some guardrails as well, which we really enjoy. Awesome. Just checking to see whether we have any questions in the live chat just before we move on. Happy to hang on for a second. We can always come back. That's okay. We can always come back. All right, now I'm going to, if by magic, we're going to have a chat with Jason all about chaos engineering. And popular subject, particularly for SREs. It's great to kind of get more information on that. I'm going to try, Rosemary, if we can, do you know how we can just get Jason over?
I think I'm already on it. So.
Oh, sweet. Fantastic.
Yeah.
All right, Jason. It's starting to get lighter in your background now, which is great. It's
yeah. So everyone gets to see the nice Portland, Oregon sunrise behind me.
Fantastic. Well, thanks again for joining such an early morning for you. But just going to hand over to you, and we're going to learn all about chaos engineering.
Cool. So I am now sharing my screen, hopefully.
Yep, all good.
Let me go ahead and pull up my slides. Sweet. Yeah. So chaos engineering. Let's talk about it. I always like to bring up this quote. So Corey Bertram is a friend of mine. He was also the VP of infrastructure and SRE at Datadog, where I worked prior to joining Gremlin. But he always said that hope is not a strategy. And I feel like that encompasses so much of the SRE role and modern infrastructure. But the reason that Corey said that is that Corey used to work at Netflix. And I think when we start to talk about chaos engineering, Netflix always comes up because everybody has heard of what they were doing. They've heard of Chaos Monkey. But I feel like so few people go back to the original blog post where they first announced that they were doing this thing called chaos engineering. And if you go back to that original blog post, it really had 5 points, like 5 things that they had learned about moving to the cloud. Really is what they were doing. They were moving from their own on-prem, running their own cloud, to moving to AWS. And point number 3 was that the best way to avoid failure is to actually fail constantly. To constantly fail, you end up learning. And so that's essentially Chaos Monkey, and we'll dive into that in a bit. But a bit about who I am. For those who don't know me, I'm Jason. I am now at Gremlin. Gremlin's a chaos as a service platform. Previously, I was at Datadog. Datadog did a lot of chaos engineering, and so that's where I first started doing chaos engineering. Prior to that, I worked at O'Reilly, the tech publisher, and MongoDB. My Twitter and my email are on this slide. Feel free to hit me up if you have questions later. As mentioned, though, Gremlin is my current employer. So Gremlin does build a chaos as a service platform. Our whole goal is to try to help you make and build more reliable and resilient systems. A few quick notes, since they are my employer, just to shout out. We do have a free tier on Gremlin now. So if you want to give Gremlin a try, it makes chaos engineering really simple, very safe. That's the URL to do it, gremlin.com/gremlin-free-software. The other thing that we've been doing, just like with this virtual meetup, everybody's gone virtual. And so one of the nice things is we've been able to run a bunch of virtual boot camps or workshops on how to do chaos engineering. We've got one coming up. It's actually going to be Friday, your time. I guess it's now Wednesday night. Time zones are a hard thing for me, especially this early. But if you hit that link, bit.ly/ce-bootcamp-anz, we've been doing a ton in the US, and I was like, we need to do some for the Australia, New Zealand time zone. So I'm going to be staying up super late in my tomorrow, which is, I think, Friday midday for y'all. So join us for that. That'll be super fun. We'll show you how to do chaos engineering. But back to that blog post, I think a lot of people are well, they think they're familiar with Chaos Monkey. And they have this idea that Chaos Monkey was just, this random script that would go and like destroy servers at any random time. But if you go back to the blog post, it really was pretty clear that it wasn't completely random. And it was actually pretty well orchestrated. So the notes here was that Chaos Monkey was actually run in the middle of business day, not any random time, in a carefully monitored environment, and with engineers standing by. Like, there were engineers who knew that it was running, who were there to be able to address those problems. And the idea behind that was it was all about learning those lessons to build more reliable systems. So in short, my boss, Colton, who started Gremlin and was part of that team, says that chaos doesn't need to be random, right? Really, thoughtful planned experiments are a much more successful and simple way to start. So be very intentional about it, plan things out. Or a better quote is the quote that I use that I've said is just don't be a jerk. If you're randomly attacking systems in your organization, if you're not letting people know, if you're attacking other teams' services and not letting them know or not sharing what you're learning, then you're a jerk. So don't be a jerk. With that said, as mentioned, I worked at Datadog and we did a bunch of chaos engineering and game days there. So I'm gonna share with you what I learned from my time there and with a little bit of sprinkling on of how we do things at Gremlin as well. I do like that term game days. Game days helps you realize that chaos engineering should be fun. It should be just like a game. But one of the things that I like to point out about games is all games have rules, and rules help you to have that fun. Those constraints provide the framework within which you can have fun. And so I like to compare game days to football matches, right? Football matches have a preset amount of time, 90 minutes. And so we would actually do 90 minutes at Datadog, 90 minutes, and we'd break that down into 30 minutes of planning because nobody wants to spend all the time like planning. 50 minutes of actually playing. So that's the bulk of your time is spent having fun. And then 10 minutes reporting. So nobody wants to spend a bunch of time playing and then have to spend the rest of the day planning or the rest of the day reporting what they did. So you want to keep those parts as small as you can and focus on that playing. And I'll show you how you can keep things down to just being 10 minutes of reporting and 30 minutes of planning. But before we do that, who's the team? All good games have a team, or at least for me, I like team sports because I like interacting with folks. Our team was small at Datadog. We usually did it with just 2 people, one subject matter expert and one SRE. And the idea here is that the subject matter expert is the person who wrote that service. They're going to be that lead developer or that lead ops person who built that infrastructure. They know the most about that system. And they partnered up with one of the SREs. And the SREs are there as your reliability experts, right? So they know how you should build things, how to make things more reliable. And by pairing up, they're able to work together. Subject matter expert knows all the quirks of that software or that infrastructure. The SRE can help inform them on maybe how to work around those constraints that they had or those quirks that they had built in to build something to be more reliable. Now, sometimes we would have a third person, and that third person was a junior engineer or a junior developer. And this was simply because as running a game day and you're exposing these issues, that junior developer or engineer often doesn't know those quirks or those constraints that were in place when that application was built or when that infrastructure was built. And so they're there to ask those questions. Why was this done that way? That doesn't seem like the right way to do it. Maybe we should have done it this way. And then your subject matter expert can actually explain what those constraints were. And it helps with that knowledge transfer. So those junior engineers now start to understand why systems were built in the way that they were. The other reason, aside from that knowledge transfer, is it sometimes points out things that maybe the subject matter expert or the SRE didn't realize at the time, that those constraints are now gone. If the junior engineer is like, hey, that seems like a really strange way to have implemented this, the subject matter expert could expose, oh, we had this constraint, but now it's obvious that that constraint no longer exists. And now that weird quirk or that nice, clever solution to that constraint is actually technical debt. And so you start to expose some of these issues. At Gremlin, we generally have larger teams when we run game days. We actually have 4 roles, but these roles are based on the action items that need to happen during a game day. So we generally break it down now into the general, the person that makes the decisions, the commander, and that's the person that actually runs the experiment, causes the chaos, an observer, which is the person that tracks that chaos through monitoring tools, through interacting with the application, things like that, and the scribe, the person that's going to actually record those notes. And so with this, these are the roles that you want to have, or the tasks that need to get done, whether you choose that small team of 2 or 3 people, or whether you choose 4 or 5 to cover these roles, that's up to you. There are advantages and disadvantages with each, but I'll leave that up to you. That said, let's keep the planning short. So before 30 minutes, what are we going to do? We're going to actually take some time and schedule this. So we want to actually, again, do it in the middle of business day, not at the end of the day, not on a weekend. Have enough time to do this. Ensure that you've got plenty of time. You're going to pick your tests. What do you want to actually do? And I recommend that you start easy. I think everybody has these grand ideas of, well, let's replicate our last outage. Well, outages are often fairly complex. So if you're just starting out in chaos engineering, highly recommend that you keep it easy. Do simple things like shutting down a service, and to see if it restarts, or spiking the CPU. Just really simple things. The next thing that you have to do is that you have to write down what you expect to happen. So just like a scientific experiment, you want to create a hypothesis here. What do we expect to happen? That way we can track whether it actually happens or not. We also want to set up some abort conditions. If things go horribly wrong, we need to define what horribly wrong is, right? If this takes down our service and is going to violate our SLOs, then we want to abort that experiment because we don't want to actually affect our customers negatively. And then we also want to write down when that failure happens, what do we plan to do? So in Gremlin, that could be simply just halting the experiment. But if it leads to a cascading failure, we need to have some sort of plan. And finally, most importantly, you want to share this. So share all of that information out as broadly as you can. If this does go horribly wrong and it affects your customers, engineering at least needs to know about it, right? So everybody who's on call, everybody who handles incidents will be aware of it. But maybe even broader, share organization-wide, maybe to even your sales folks, your account executives, because if a customer is affected, they might be reaching out to figure out what's wrong. And so having broader knowledge across your organization is useful for sharing that information. When it comes to the actual playing, how should you do this? Well, I do recommend that just like your code, you start off in staging. Don't immediately jump to production. Start off in a staging environment or a development environment where things are safe. Then move to production, maybe on those off-peak hours where traffic is a bit lighter, so you don't affect too many customers should things go wrong. And then finally, you have to try it in production during prime time when all of your customers are there, because if you never check in production, just like code is never truly deployed until it's in production, if you don't do chaos engineering in production, you'll never have that guarantee that any of the work that you've done to make your systems more reliable or resilient, you'll never have that guarantee that they actually are. To kick it off, you'll announce this in group chat. I highly recommend that you do everything through group chat. I think now, especially with our current pandemic situation and everybody working remotely, everyone's relying so much more on Slack. But even as this situation gets better and you move back into your office, it can be easy to turn to that colleague next to you and just dialogue with them. The problem is this makes your dialogue much harder to track. So if you're keeping everything in Slack or whatever group chat you've got, it makes it easier later when we do the reporting to just link back to that discussion. Makes it easier to not have to take such detailed notes. So you want to maintain that discussion in group chat as well, because again, just linking back to it makes it super easy. You do want to monitor for outages during this. So you'll keep an eye on if you've got an incidents channel in Slack, you want your monitoring tools up, your dashboards, everything available. So you can keep an eye on your broader systems as well. Because again, you don't want to affect other teams if you're just trying to test your own systems or your own services. Finally, run your tests and take notes. So break something and take as good as notes or as detailed of notes as you can so that you can learn from it. Afterward, so again, keeping this super simple, trying to keep this to under 10 minutes or about 10 minutes. First thing you want to do, create cards or tickets to track whatever needs that work. So whether you're using Jira or Trello or any other tracking tool, I think as we all know, if you have something that needs to get done and it doesn't get a ticket, it doesn't go into whatever tracking tool you've got, it never actually gets done. So ensure that you create those tickets. That's the first thing you need to do. The next thing is just write up a summary and some key lessons. If you've been taking good notes, the summary really should be fairly simple. A lot of times you can just copy and paste what you've got. You're going to email that out, at least to all of your engineering teams, because the technical learnings that you find will be useful to them. So again, chaos engineering, all about learning, and you want to share what you've learned to other teams so that they can get better as well. Then you want to celebrate. So celebration is very important. One of the things that I loved about working at Datadog was they love to celebrate. And you want to celebrate if things go right? If we launch a chaos attack and all of our systems survive, it's almost as if nothing ever happened. Well, then celebrate that, because you built a truly reliable, robust system that's impervious to whatever that attack was. That's a great reason to celebrate. Conversely, if you launch a chaos engineering attack and not only did it take down your service, but it led to a cascading failure and it took down your entire application, well, number one, fix that. Don't just leave that. But number two, celebrate that, because you just found a critical flaw and you're working to resolve that. It could have been much worse, right? That outage could have happened in production without you knowing about it, and it could have taken everything down and lost your company, millions of dollars of revenue, but you found that beforehand. So celebrate that you actually discovered something new, that you learned about something. Celebrate that you have a way to become more reliable and that you actually have that in your tickets. With all that said, I did say you should start simple, but how do you progress? So this is how we did things at Datadog. We would start simple, just terminating the service. So if I turn it off, if I kill that process or I kill that pod, does it actually restart? These are pretty simple things. Your service should be able to restart without any manual intervention. We would also at this level block access to one dependency. At this point, you don't have to survive this attack. If you block access to a dependency, it may be critical, but we want to at least verify that our service reacts the way we want it to, right? So if a dependency, some other service that I rely upon goes down, at least I should have some logging, or at least I should throw a reasonable error message to my users. The next level that we graduate up to is blocking access to all dependencies. And again, your service doesn't have to survive. If I block all of the access to all of my dependencies, things like databases, if I have an application that primarily does CRUD on, creating records, updating them, deleting them, and I don't have that database, well, obviously that's not going to work. But again, we want to verify that it acts the way that we expect it to, that it is generating good error messages to our users, that it's throwing the right alerts when we have it, that the monitoring is in place to know that it's in that state. After that, we terminate the entire host. So if you're on a virtual machine, we'll terminate that. If you're on Kubernetes, we'll terminate the node. And we would expect that whatever cloud provider we're in would automatically see that and regenerate that host. Whether, again, if we're using Kubernetes, then it would just regenerate that pod. If we're using VMs, that it would just automatically spin up a new VM for us. We want to verify here that we're able to reboot that, or that if we've got any sort of failover to a different availability zone, that it'll do that. And that all traffic is automatically redirected. We also want to ensure that we have the proper monitoring at this point, that when that monitor gets thrown, it's alerting the right people, that it's generating links back to the correct runbooks, and that those runbooks have all the right steps in them. Level 3 is where we degrade the environment. So we would ensure that we have monitoring and alerting on latency, errors, traffic, and saturation. But degrading the environment really was things like mostly the network. So dropping packets, introducing extra latency, doing things that are a bit more weird, right? It's not, most of our systems don't exist in a simple on or off state, whether service is up or down, they usually exist in these weird in-between states where they're not optimal, where the network has high latency, or where services become intermittent. And we want to be able to detect those. So we wanted to have full monitoring. One of the things about this level, though, that was highly important is that at Datadog, all of our service owners, all of our developers were on call for the services that they wrote, that they owned. This meant that SREs didn't have to take care of them until this point. Once a service owner had reached level 3 of game days, that ensured that they had all that monitoring, that ensured that all their runbooks were correct, that everything was documented, well, that was the point at which they could pass off on call to the SRE team. And the reason for this is that now you have all this documentation, you have everything codified, that the SRE actually has that information to take over and be on call. The worst thing that I've experienced in my career working in tech is when you had ops people or SREs on call for things that didn't have any of these basics, right? I think it's very common for developers to write applications, operations to deploy them, and then an ops person is suddenly on call for something they know nothing about, that doesn't have any monitoring, that doesn't have any runbooks. And so they get woken up in the middle of the night and they get this alert that, you know, web application is down. And the first thing that they do is, well, what is web application? What's it supposed to do? Where is this even? What's the dashboard for it? And so then they have to like scramble and figure out all of this stuff, or they just get really angry and they immediately call that application owner and say, hey, I got an alert. You have to go fix this thing. Why did I get woken up in the first place? I'm just the middleman. And so this is an important thing. So I highly recommend that for anybody. Put your application owners on call, make them get to a basic level of sufficiency or reliability before you pass off that on call. After that, we'd start to get into some other fun games. Spiking traffic was level 4, so we would just hammer and DDoS our systems to verify that auto scaling worked, to verify that asynchronous calls could happen. So a lot of Datadog's pipeline is the idea of ingesting metrics and having a bunch of systems access those. That can ideally be done asynchronously. So we'd put those into a Kafka queue, and then things could work asynchronously. And then level 5, which we didn't always get to for every service, but this is the ultimate goal, I think, of most companies is, what if an entire region or entire cloud goes down? You know, if AWS has an outage, can we pivot and run off of Google or off of Azure or some other cloud provider? With all that said, I think hopefully I've got a little bit of time. We can run a simple experiment. Yeah, cool.
Yeah,
well, Bruce, you are an SRE. I set up a fun application here. So how about we'll be our tag team?
Sure.
Cool. So I've got a basic application here. It's just a WordPress website. I'm going to go ahead and refresh that. I think it should still be running, but I've actually got it running in Kubernetes. So if I do something like, hello, whoa, I am beach balling. Oh, there we go. Running too many things at once. Hopefully this is still up and running. There we go. Cool. So yeah, I'm running basic Kubernetes application. It's WordPress. So we can see that I've got Datadog running for my monitoring. Gremlin is running because that's how we'll launch our attacks. I've got the WordPress application. So for anybody following along that hasn't heard of WordPress, it's really just a PHP-based content management system. It's used for blogging. So it's PHP on the application tier, and then MySQL as the database or the data store. So pretty simple. And it looks like this. So I've never actually been to Perth. Now I really want to visit because the skyline looks amazing and that waterfront looks really fun and this crazy bridge. Yeah. So I've got that running. So let's dive into our plan. Let me biggerize this. Oh man, why is my... Well, hopefully that'll... So scheduling it. We're going to schedule it. It's happening now. Normally, you'll want to schedule this well in advance so everybody knows. We're going to choose tests. Let's kill the database. And then the important part, what's our hypothesis? So if we kill the database, what do we expect to happen? Any thoughts, Bruce?
Yeah, I think we'll just get database is going to go down, which means we're not going to communicate or pull down any images or click on anything. So yeah.
Yeah, pretty much the site should go down, right?
Yeah, basic functionality is going to go.
Yeah, I'm going to add in here that like monitoring, we should have some sort of alerting on this.
We'd hope.
We hope. Abort conditions and what do we do if something goes wrong? Well, abort conditions, since this is just on my local machine, which is probably why my computer is being extremely slow. We don't really have any, but abort conditions would be if customers can't interact. That won't actually happen. And if things go horribly wrong, well, this is, again, it's just my local development. So there's nothing really other than, I would say, let's reboot, because it is my local machine. Normally, these things would be like, though, if your customers can't interact with the site, then you'll halt the experiments. And if things go horribly wrong, we'll investigate, we'll escalate to the actual SREs on call. And then we'd share this out. So that's pretty simple. So with that said, let's go ahead and jump into this. I've got Gremlin running here. I'm going to go ahead and click over to my attacks. And let's say a new attack, and I'll select containers. Let's look for my MySQL. So there's my container. So one of the nice things about Gremlin is I could do this a number of ways, right? I'm in Kubernetes. I could kill the pod. I could scale it down to 0. There's a bunch of ways to do this. One of the nice things about Gremlin is Gremlin's default state is to be inactive, to not run any attacks. And the great thing about that is if you run an attack and anything goes wrong, it's going to default back to that safety state of not doing anything. There have been so many times when I was doing chaos engineering before Gremlin where I'd kill something or I'd log in and I'd be like, let's try to test the network. And I'd kill the network and realize that I had just killed my SSH connection to that. So I had no way to log back in and actually reset it. So this does make it a whole lot easier. So I'm going to select network and black hole. Black hole is essentially going to kill the networking for that MySQL container. It's going to cut it off, pretend that it's gone dead. I can leave all the defaults and I can go ahead and click Unleash Gremlin. That's going to go pending. And then it's going to end up running and I can start to refresh this. So that reloaded pretty quickly. So I'm just going to keep refreshing this. Oh, so now I'm spinning. That's probably hard to see because it's small, but that isn't loading. So it's just waiting there. I'm going to flip over to my monitoring here, see what's going on. So it looks like MySQL is still up and running. Not getting any slow queries. Connection so far hasn't dropped down. Let's see if this is, no, did that reload? One of the other things that I'd expect if the site goes down is probably some sort of useful error message. But it looks like it's just spinning. Let's just double check to see. Yes, my attack is running. So my monitoring's in place. We have seen network traffic here, though, has dropped. So yeah, we are definitely not getting any traffic on our database. Cool, so it looks like my monitoring's generally working. This is still spinning. So we finally got our error message. That did wait a long time. So if we're taking good notes, things that we saw connections, drop in monitoring, and we saw that the website threw an error message. And that took a while. So one of the other things that we may want to actually do for this is put something in there about timeouts. We could potentially tune that. Anything that we didn't expect, I think that pretty much went according to plan. So that's a good thing. That's a good reason to celebrate. Anything that we should change or fix. So, again here, I think, well, if the database goes down, we should probably serve up some sort of static HTML site, right? That looks better. So let's, yeah. Cool. So this is a super simple example of a chaos engineering experiment, but the idea here in keeping that reporting super low is making tickets. So we have our things that we can do and just copy and paste this, right? So we can just copy and paste things we should change and fix, make tickets out of those, write up a summary, and that's that we saw the connection drop. We should actually check to see if it's back once. So it does come back once the attack is over. So that's nice. So yeah, we have our basic summary here. We have our tickets. We would share this out and we would celebrate. So super simple there, but congrats. It's really easy experiment. Gives you an idea of how this actually would happen. But just to recap, the important points of this really are that you should spend some time in planning. Don't do chaos engineering randomly. You should share your information, share your plans so people know that you're running experiments, share what you learn afterward, and definitely have fun with this. It's pretty fun to break things and figure out how they work. I like to equate it to when you were a kid and you were like, what's this gadget that I have? How does it work? And you took it apart. Hopefully you were able to put it back together, at least most times for me, but not always. Sometimes I'd have an extra screw. A few additional resources though. You could do chaos engineering with a lot of stuff. As much as I work for Gremlin and I'd love to have used Gremlin, there are a bunch of tools that you can use out of the box that come with your system. Things like systemctl, kill, IP tables. There's a bunch of ways that you can test what you're on. Just make sure that you're being safe with those. It's easy to update some of these system settings or use some of these system tools and get into a bad state. StressNG is a Linux tool. It's a great way to stress out your CPU, eat up IO, eat up memory. Comcast is one that we used at Datadog. It's a way to simulate poor network conditions. So that's a fantastic tool. Vegeta is another one. Vegeta is essentially a DDoS tool. So you can do load testing on your own systems. And it has a nice interface. You're able to feed that data back in. You can think of it as like Apache Bench on steroids. And also Gremlin. Also, I believe that's the wrong URL. So I will quickly flip to this one, which has the right URL. So you can get Gremlin for free. That's the URL for it, gremlin.com/gremlin-free-software. Also to reiterate, if you actually want to get more hands-on, we are running that workshop. So that'll be Friday. That's the link to go ahead and register for that. So would love to have you join us. It's a super fun workshop. We get more involved. We break up into teams and actually run some real experiments. So with that,
awesome.
Yeah.
That's great work. That's awesome, Jason. I've actually did the London bootcamp last week. Just I didn't realize there was one for Perth, which would have been a much better time for me, but that's fine. But yeah, incredibly useful. Going through and running a few of the scenarios and tests, and actually going through and taking those roles on. Really useful to kind of play out. So yeah, if anyone's going to, if anyone wants to know more, I would definitely jump onto that bootcamp. Super useful. Cool. Awesome. That was incredible, Jason. I really enjoyed that. Just wanted to see if anyone wants to comment or ask any questions in the chat. Glenn just mentioned, the times is a little bit different for Perth. I think we're 10 or 11 o'clock. I think 11 o'clock in Perth, so that's much nicer, just before lunch. And no, so Jason, so what's the best contact for you guys? So like if anyone's got any questions, can they shoot you any messages?
Yeah, absolutely. So I'm just JYEE at gremlin.com, or I'm getbisect on Twitter.
Oh, nice. Awesome. Fantastic. And Rosemary, I know you already mentioned that you put your contact details up there. So if anyone wants to get hold of you or just Slack you any questions, you cool with that?
Yeah. Feel free to
Sweet.
just send me a tweet.
Fantastic. Awesome. I've got to say thank you so much for taking the time this morning. I know it's early for both of you and particularly early for Jason. I really appreciate you taking the time to talk to us for the Perth HUG community. Really appreciate it. So I'm going to probably end it there, but it's been tremendous. And if we do have another meetup in the future, we'd love to have you guys back at some point. But thank you again so much for taking the time. I appreciate it.
Absolutely.
Thank you, guys.